Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Moore's Algebra 2 class. Today we're going to talk about solving compound and absolute value inequalities. Before we start looking at the inequalities, let's consider the following two sets. You have set A, which is 1, 2, 3, 4, 5, and you have set B, which is 3, 4, 5, 6, and 7. If I ask you to find or list rather the numbers, all the numbers that are in both A and B, when you look at these sets, you should hopefully see that you have 3, 4, and 5 that are shared in both sets. When you're looking for this type of setting, you are looking at what's called an intersection of sets. These are the values that are in both sets. If I were to ask you to list all of the numbers that are in sets in A and B combined, then I take all of the values of set A, all of the values of set B, and I write them all down together. That is called a union. And if I were to do that, it would be 1, 2, 3, 4, 5, 6, and 7. An intersection of two sets, A and B, or however many sets, is denoted by A and then this upside down U, then B. That means that there was an intersection, okay? And this is the set of all elements that belong to both sets A and B, okay? The word "and" implies an intersection. The union of two sets A and B is denoted by A in union with B. And this is the set of all elements that are in sets A or in set B or in both A and B. And the word "or" implies a union, okay? So intersection and union are very, very big. How does this relate to compound inequalities? Well, with compound inequalities, they consist of two distinct inequalities joined by the word "and" or the word "or", okay? The graph of a compound inequality with the word "and" contains the overlap of graphs of two inequalities that form the compound inequality. When you have a compound inequality, guys, you have to realize we're talking about "and" ones. You're going to have two different inequalities that are combined together to form one inequality. For example, if I have x is greater than or equal to 3, okay, greater than or equal to 3, we're going to go this way. We already learned set notation and interval notation, so we know that it's greater than or equal to, so it's a bracket. If I look at the other inequality for this compound inequality, it says x is less than or equal to 7. Well, if x is less than or equal to 7, that means I have a bracket and I'm going this way. When I have a compound inequality, what's happening is that I'm combining both of these graphs together, both of these inequalities together. So when I look at x is greater than or equal to 3 and x is less than or equal to 3, what's happening is I'm taking my x is greater than or equal to 3 and I'm combining it with my x is less than or equal to 7. And guess what? You have this intersection right here. Okay? And that is an intersection. They intersect where? Between 3 and 7. This compound inequality can be written as x is greater than or equal to 3 or x is less than 7. A lot of times people get messed up, and what they do is they read from the number, and that's very inaccurate. So please do your best to remember that you always read from the x. X is greater than 3. X is greater than 3. But x is also less than or equal to 7. So that means that it's everything in between these two parameters. And that's what's happening in a compound inequality. Okay? And again, it is read as x is greater than or equal to 3 and less than or equal to 7. Now, let's look at the ors. The graph of a compound inequality with the word "or" contains each graph as well of the two inequalities that form the compound inequality. When I'm looking at an "or" compound inequality, check out what's going to happen. In this particular case, I have x is less than or equal to -2. So I have x is less than or equal to negative 2. I'm going that way. And I have x is greater than or equal to 1. So I have my bracket, and I'm going this way. If I want to combine these, okay, I want to unify these together as one compound inequality, I am looking at x is less than negative 2 or x is greater than or equal to 1. When I have an or, think about it, it's an either or. It's not a situation where both things are intersected. These are two different possibilities. So I have x is less than or equal to negative 2, okay? Or x is greater than or equal to 1. So I have two different possibilities here. I am saying that the x values can be less than or equal to 2, negative 2, or the x values can be greater than or equal to 1. And that's how an or equation is going to look. We can also write this kind of an inequality as so. X is less than or equal to negative 2, or x is greater than or equal to 1. However, since this is an or equation, you have another option. Since you have two possibilities here, you can also just simply say x is less than negative 2, write the word or, x is greater than or equal to 1. Okay? Now, as far as writing the answers to this in interval notation would be concerned, I'm going from negative infinity to negative 2. So I have parentheses, negative infinity to negative 2. In union with 1 to positive infinity. So that's how you graph it. You have the set builder, and you have the interval notation. All of this is very, very important when you're actually solving these inequalities. Are there any questions so far, gentlemen, before I move on? Yes, sir. Thank you. Thank you very much, my brother. I put brackets because it's greater than or equal to or less than or equal to. Infinity, if you remember, never has brackets. It always has parentheses because you can never equal infinity. Infinity goes on forever. Okay? Thank you very much, my brother. Any other questions before I move on, gentlemen? Yes, sir. Yes, sir. For the infinity, I put a negative infinity and positive infinity. Yes, get into that habit, sir. Yes, again, when you have a negative infinity, put a negative. When you have a positive infinity, put plus, please. That way you know how to differentiate it, okay? If a lot of times people don't tell you to do that, and then you get lazy and you forget to put the negative, and then you get messed up. So this way, if you just put the negative and the positive, you always know which infinity we're talking about. Thank you so very much. All right, guys. So let's talk about how to write some inequalities first before we solve equations or inequalities. What compound inequality represents the phrase, I'm going to give it to you, and then graph the solutions. So all real numbers that are greater than negative 2 and less than 6. Well, in this particular case, I'm not too much of a stickler for graphing. Always put a 0 as a reference point, and then I have a negative 2, I have a positive 6. So all numbers that are greater than negative 2, parentheses, and I'm going that way, but wait, and they're less than 6. So parentheses coming in this way. And you're done. How would I write this in interval notation? Yes, sir. Excellent. If you remember from our last discussion with inequalities, once you have it graphed, guys, it's really simple to write it in interval notation. You just literally are following what's up on the graph. Give me 1 second, please. Okay. Thank you for that, guys. Sorry about that. Okay. How about all real numbers that are less than 0 or greater than or equal to 5? Well, in this particular case, less than 0, parentheses, to the left. But it's also greater than or equal to 5. So I have my 5 bracket, and I have a greater than. How would I write this solution in interval notation, gentlemen? Yes, sir, my brother. Negative infinity to 0 with parentheses because it's just less than, not less than or greater, not less than or equal to. Awesome. Union with? Yeah, bracket. Pay attention, Mr. Morrow. Bracket. 5. That's it, my brother. Perfection. That's interval notation for this. Now, let's get to how to solve these, y'all. What are the solutions of this inequality here? And I want you to graph the solutions. Whenever you do this, Robert, yes, sir, what do we got to do? That's right, you're going to treat it like an equation. Very awesome. Okay, usually when we deal with equations or inequalities, there's just one side, okay, but there's two sides here. So what happens is I'm going to add 4 to every single side. If you do not do that, you will not have a balanced equation or inequality, rather. You will get the wrong answer. So in this particular case, I have negative 3 plus 4, which is 1. My m is now alone, and this equals 3, and I'm done. I have m is greater than or equal to 1 and less than 3. So let's graph it. 0 as my reference point. Here's 1. Here's 3. M is greater than or equal to 1, but less than 3. Less than or equal to, sorry. Thank you, sir. Thank you, my bad. Thank you. So how would I write this as interval notation? The solutions here. Yes, sir. Yeah? That's it. The graph relates identically to the interval notation. How about example 3 here? How would I start solving for this, my brothers? Yes, sir. You add 4 to both sides. That's fantastic. And that's going to give me, sir?
2.
Yep. Yes, sir. Awesome. And then how do I solve for y, my brother? You divide 3 to every side. And then, so y would be greater than 2/3, but less than. Awesome. Graph it. 0 is my reference point. Here's 1. 2/3 is about here. And then 6 is over here. Parentheses, that's okay. Parentheses on 2/3. And I'm going towards the 6. Yes, sir. Parentheses on the 6. And I'm going towards the left because it's less than. How would I write this in interval notation, my brother? Yeah. Comma 6. Perfection. Does that make sense? Questions, problems, concerns, issues? May I continue? Yes, sir. Okay, I understand you're writing it down, but there is a video for this, so watch it later. Thank you. Okay, now, word problems. To earn a B in your algebra course, you must achieve an unrounded test average between 84 and 86 inclusive. The word inclusive, I put this word here on purpose. You will see this on the SAT a lot. Inclusive means it includes 84 and 86. So that means it's going to be an equal in there. There's going to be a greater than or equal to or a less than or equal to. Inclusive means that both of those numbers are included. You scored 86, 85, and an 80 on the first 3 tests of the grading period. What possible scores can you earn on the 4th and final test to earn a B in the course? Well, you're going to have to go back in time and remember the formula for average. Does anyone remember the formula for average? Yes, sir. Very good, my brother. The average is the sum of values divided by the total number of values. That's what average is. Now, in this particular case, You have two averages, though, that you're really trying to shoot for. You want to shoot for an 84, between an 84 and an 86. And to get there, your average has to be between an 84 and 86. So the average that you have so far would be an 86 plus an 85 plus an 80 plus your fourth and final test, which is X, divided by 4 tests. This average must be greater than or equal to 84 or less than or equal to 86 in order for you to get a B. Yes, sir. No, it's the fourth and final. It's the last test. Thank you, sir. Okay? And now it's Mickey Mouse Town. First thing we're going to do is we're going to add up all these like terms here. So 84, and then 80 times 3, that's 240, and 11, so 251, plus X over 4 is less than or equal to 86. My brothers, how do I get rid of that denominator of 4? Yes, sir. Excellent. So you multiply 4 to everything. 4 times 84, we got 320 and 16, so 336. 250, I'm sorry, 4 times 251 plus X over 4, the 4's cancel. So I just have 251 plus X. And 4 times 86 is 320 plus 24, so that would be 344 points. Subtract 251 to both sides. And I'm going to have here an 85. And over here, I'm going to have, bless you, a 93. So in order for you to earn a B in that class with the current average you have, you would have to have a test score that is between 85 and 93. And that's the power of inequalities. Yes, sir. Okay. When I multiplied 4 to here, what's 4 divided by 4? They cancel. No, thank you so much. That's how you learn. Thank you. Sir.
Yeah, why'd you pick 86 plus 85 plus 80?
I didn't pick 85 plus 86 plus 80. I read the problem. Guys, in word problems, I find that the number one problem with word problems is that you don't read the words. If you don't read the words, gentlemen, you're going to have a very difficult time solving word problems. You must read the words. Okay? Now, let's try an OR problem. When you have an OR problem, gentlemen, it's very simple. All you got to do is solve each inequality separately and then combine the answers. So literally, you're going to first solve this guy. I'm going to subtract 2 to both sides. 3x is less than negative 9. Divide by 3. Flip the sign, right? I caught somebody. Someone said yes. No. You only flip the sign when you multiply or divide by a negative, not to a negative. Then let's go ahead and solve this guy. Subtract 5 to both sides. Negative 4x is less than or equal to negative 4. Divide by negative 4. Now I flip the sign because I divided by a negative. So my answers are x is less than negative 3 and x is greater than or equal to 1. So let's graph it. So my negative 3, here's my 1, less than 3, parentheses to the left. Greater than or equal to 1, to the right. How would I write this as interval notation? Negative infinity to negative 3 in union with 1 to positive infinity. Does that make sense, gentlemen? Promise?
Wait, so
Yes, sir, my brother. Talk to me, my man.
good.
Thank you, sir. Yes, sir. If it was an and, you wouldn't have this kind of a graph. If you had an and, it would be a graph where it's in between. No, no. Okay, let's go back. This is an and, son. This is an and. Done. It's an and. It's an intersection. Okay? This over here is an or because there are two sides to that coin. There's this side and there's this side. So the union is for the ors. It's a union. The and is an intersection. That's why you don't put a U for it. Now, could you put an upside down U? Yeah, but it's not really very efficient. Follow the graph when you're writing down your interval notation, sir. Thank you, son. Does that answer your question, my man? Thank you, sir. God bless you. Awesome. Alrighty. Let us continue then. Thank you. All right, I want you to solve these guys right here. So let's solve each individually. Subtract 7 to both sides. Negative 2y is less than negative 6. Divide by negative 2. And y is greater than 3. Please note that I flipped the inequality sign. Why did I flip the inequality sign? Because I multiplied by a negative 2. And then on this side of the equation, I got negative 3 that I subtracted both sides. 4y is less than or equal to negative 8. Divided by 4. Y is less than or equal to negative 2. Notice I did not flip the sign because I did not multiply or divide by a negative. Now let's graph it. I got 0, and I've got negative 2, and I've got my 3. Y is greater than 3, and y is less than or equal to negative 2. So my solution here would be negative infinity to negative 2 in union with 3 to positive infinity. Does that make sense, gentlemen? Yes, sir, my brother. Yes, sir? Yes, it does matter hugely. You always read from left to right. Guys, I will repeat myself. The graph tells you exactly how to write the interval notation. The graph tells you exactly how to write the interval notation. Seek to the graph for the answers. Thank you, sir. All right, now let's get a little bit more complicated here. I've got 3/4 times x plus 4 is less than or equal to 1, or 3/2 times x plus 1 is greater than or equal to 15. How would I solve this? Well, you can distribute if you want to, but I showed you a much easier and better way. No? Okay, you multiply everything by 4. Now, what am I multiplying this 4 to? Let's see if you guys remember. Yes, sir. I understand that, but there's a lot on both sides. The 3/4 only and the 1. Why am I not multiplying it to the x plus 4? Because it's in parentheses. Thank you. I'm affecting this number here. Once this number is completely affected, then I can distribute. So 4 times 3/4 is 3 times x plus 4. Less than or equal to 4. Now I can distribute if I so choose. 3/6 plus 12, 3x rather, is less than or equal to 4. Subtract 12 to both sides. 3x is less than or equal to negative 8 divided by 3. x is less than or equal to negative 8/3, which is 2 2/3. On the other side of the coin, how do I solve for this bad boy? What's a nice easy way to get rid of that denominator of 2? Multiply by 2. What's getting affected here? The 3/2 and the 15 only. So 3/2 times 2 is 3 times x plus 1. It's greater than or equal to 15 times 2 is 30. 3x plus 3 is greater than or equal to 30. Subtract 3 to both sides. 3x is greater than or equal to 27. Divide by 3. And x is greater than or equal to 9. And now, let's graph it, and let's write the solutions. So 0, here's negative 1, here's negative 2, here's negative 3, negative 2 2/3 is about here. And that's less than or equal to, so I've got a bracket, and I'm going this way. I know it's going to be one of these because it's an or. And then on the other side, I have 9, and it's greater than or equal to. My solutions, I'm going from negative infinity to negative 2 2/3. Excuse me. In union with, I'm going from 9 to positive infinity. Does that make sense, gentlemen? Yes, sir. Come again? Yeah, they would be brackets. Thank you. My bad. Thank you, son. Now, for example 8, it says and. So is this going to have two sides, or is it going to be an intersection? It's going to be an intersection. Sometimes you have it as a compound inequality. Sometimes you have it as separate inequalities like this. So I'm going to subtract 3 to both sides. Negative 8x is less than or equal to negative 8. Divide by negative 8. X is greater than or equal to 1. I flip the sign because I divided by a negative. And then here, I want to get rid of the fractions. So I'm going to multiply everything by 3. 3 times 2/3 is 2x. 3 times 1 is 3. And 3 times 3 is 9. Subtract 3 to both sides. 2x is less than or equal to 6. Divide by 2. X is less than or equal to 3. Now when I graph this bad boy, x is greater than or equal to 1, but less than or equal to 3. So it's everything in between. My solution's 1, 3. Does that make sense, gentlemen? Questions, comments, concerns, problems? Give me 1 second. So we're good, guys? All right. Let me give you one more, something that I would put on the test kind of thing. Okay. What if I were to give you the following? Let's go. All right, and then let's do. All right. What do I do here, guys? Tell me what to do. Very excellent. Add 8 to each side. Great job, guys. So that's going to give me 5. Excellent. And then divide by 5. So x will be less than 1 and greater than 5. So x will be less than 1. Less than 1. And it will also be greater than 5. So even though I didn't put an and or an or word here, what kind of an equation is this? Or inequality? It's an or. So it's going from negative infinity to 1 in union with 5 to positive infinity. Does that make sense, gentlemen?
Yes.
Questions, comments, concerns, anything at all? Yes, sir. Thank you, sir.
I understand when we use the regular U, but
The union. You're very rarely going to use the intersection.
okay.
The intersection, when you have an intersection, you're going to have a situation where it's between two numbers, so you don't need it. All right, my man? Thank you so much. Because if you really did the intersection here, let me show you why we just contain it like this, my man. Instead of me just telling you that's the way it is, let me show you why. Technically, this is the following. I'm going from negative 3 to positive infinity, intersecting with negative infinity to 5. That's what's really happening here. But sometimes this infinity throws people off. And they don't realize, oh no, I'm not actually going all the way to infinity. I'm actually between negative 3 and 5. So this is the technical way, if you want to say it, but it's not the actual usage way. The usage is between these two numbers. I'm done. Thank you, my man. We're all good, brothers? All righty. Thank you very much. Hope you learned a lot, and have a wonderful day.